So then the question is, well, why? Like, why use this for colors? And the reason is because pictures have to get stored somehow, right? And the way you store a picture in a computer is you basically need to write down a bunch of things. So let me think about a computer as just a whole bunch of transistors all in a row, right? Little switches that are either on or off, right? This is a little bit more general than a computer, but oh yeah, and then computers have finite memory, right? So let me not make a Turing machine up here, but instead make a computer. Cool? So I have finitely many little spots. I would like to fill up these little spots with a picture, right? And so the way I fill up spots with a picture is all I'm allowed to put in each one is on or off, right? Like that's all they can be. So I think about a picture like this. I go, picture. Picture is made out of little dots of colors, which you would recognize as, no, as pointillism. It's a painting style, right? You take a brush and you dip it in one little color and put a dot, and then you clean it, take another color and dip it. Yeah. So this is basically like computer images are essentially pointillism to the max, right? So you have all these little squares, right, that you're gonna let your computer do some, like your monitor, right, is going to display some kind of red, green, blue mix using one of those little like variable color diodes, right? Like give or take. That's not actually how the computer monitor works, but you can. Cool. So I need for each little spot here, I need one, which spot is it, and two, what color is it? The two, what color of is it, is actually 3 parts. So you do one is kind of where, and then 2 is color. And the way you express color is you do a red, green, and a blue, right? So you have like color part A, color part B, color part C. You do red, green, blue.
Would things like gamma be included in color, or is that an alternate thing?
Yeah, so if you, depending on the compression algorithm you use, or depending on the code, depending on how the file is made, essentially, this might have a longer list. Right, so if you go look at a PNG file, or the way that a PNG is made, it'll have a red, green, a blue, and an opacity, and possibly some more stuff depending on the header of the file. So like someplace in the front of the file, there's a little chunk of code that says, yo dude, this file is intended to be a PNG, and it has the following properties. Right, like
JPEGs are always garbage. They use less quality, fewer of those things.
JPEGs are what's called JPEGs are made by compressing. So this thing that I'm describing to you is what's called a raster image. This is where each and every pixel has values that are associated to it. A JPEG is a compressed raster, so it takes all this information and like does math and statistics and massages it and gets like some kind of other something. Like the dumbest method that you could use to compress a photo. Sorry, I say that like it's the first method you could use to compress a photo is you could just like look at the photo and be like, this chunk is all basically blue. So instead of coding out all those pixels, right, with 3 kind of long values for the colors, I just say like blue, and then list where they are. You guys see that? Like that'll save me a lot of space. And that's actually how some of those algorithms work. Some of them do this, some of them do fancy ass statistics where they like predictively color between interpolating them. Like pick a couple pixels basically, and then like notice that there's a gradient in between those 2 pixels, and so then they fill in that with information about a gradient between these two pixels and not information about the colors of all the dots in between. So you can save a little area doing that, or a little memory doing that. But the thing about hex, basically, here, is that you just go through the list of pixels, one pixel at a time, and allocate some transistors to it. Right? So you say, okay, first pixel is going to be this one. Second pixel is going to be that one. This is going to be the width plus 1 pixel, right? Or the width pixel, depending on how you count, right? I said first. I really should have said 0th. But whatever. Come up with some counting scheme, right? And then you're going to have some little bit of your file, right? That's going to be like a header. And that's going to essentially tell the computer what this crap means. Like, how many little transistors am I allocating to each color? Right, that would be, am I doing 8-bit color or 24-bit color or whatever. It'll tell you essentially how many bits to expect for each color. And then you'll just encode the where by where it is in the string. Right? So then you'll do, these guys are going to be first pixel red, and then the next ones of the same size. Right? Because even if there's no green, you still want to fill up the same number of switches on or off. That'll be first pixel green. And then your next bit will be first pixel blue. And then you'll go into second pixel red. Right, and kind of so on and so forth.
It's not each dash is where, then red, green, blue. It's each group of 4.
It depends on the encoding, right? But yeah, it's each group of some specific size. Probably 8.
We're quickly approaching an arbitrarily large number of transistors.
Yeah, these do get big fast, right? You guys see that? Like, this gets really big really fast, which is why video processing is still the most intense thing you can do to a computer, basically. Right? Because video processing is basically doing a shitload of this, right, for every single image, and running them through at 60 hertz, right? So you have just a crap load of images that you need to kind of deal with and then compress. And yeah, this is a lot of stuff, right? Is exactly why the first thing you would do is be like, yo, dude, I'm not gonna mess around with the blue pixels. I'm just gonna write, these pixels are this color and list where they are. And then I'm gonna make another list. I'm gonna be like, these pixels are this color and here's where they are. And if I was doing an even worse job, I'd do, these pixels are close to this color. Here they are. Like, these are close enough. Call them all this color. And that's essentially how compression works. Cool with that? And then video compression is another cool thing, right? Because a way you could do video compression is you could do which areas of the frame have changes in them. You guys see that? Like, most of this movie is remaining exactly the same. I'm moving around, right? But like, that stuff over there isn't moving. And so the compression algorithm could cut out the area that's changing every time and say, for the rest of it, see previous image. You guys see that? And that's kind of how video compression works. These things, like compression algorithms right now, I'm really glossing, because compression algorithms get super, super complicated, and there's a shitload of money to be made in making better compression algorithms. Cool. Like, statistics is super cool in there. There's a lot of really neat math that goes into doing good compression, and I'm fully glossing over it. Cool. If you open a JPEG or a PNG in a text editor, which seems like really weird, but if you just change the file extension to .text and then open it, it looks like a bunch of garbage. Like a bunch of weird Unicode characters. And the reason it looks like a bunch of weird Unicode characters is Unicode characters for a text editor are rendered in little blocks in hex or in binary, right? And in here, there are little blocks that have hex or binary in them. And so when it reads them, it sees stuff that it recognizes. It's supposed to be rendering that stuff as color, right? But it knows how to render that stuff, so it renders it as weird characters. With the exception of the header area. The header area oftentimes has a few coherent little bits in it. Like if you open a JPEG file, sometimes you'll see JPEG. Sometimes you'll see what editor was used to make that JPEG. Like I opened one on my laptop this morning and saw Photoshop and a big tag there. Other times those little headers have things about the compression. They'll tell you like what color scheme is this intended to be in, when was this file made, stuff like that. What's up, Ben?
I was just going to say a fun thing that some people were doing last semester is they would pop open a picture they did not care about in text, and they just start messing with the numbers, and they get like they see how the picture changes.
Yeah, and that's definitely a thing you can do. You can open a JPEG with a text editor, right? Grab a whole bunch of those weird characters and start putting in weird characters of your own and see what it does. It'll totally work. It'll basically change the colors of the pixels, right? But you can see which blocks are which is kind of fun. Another thing you can do is you can open them in what's called a hex editor, and then you can just directly fiddle with the pixels. If you open them up in Photoshop or something, Photoshop is just like a fancy-ass text editor. Like, really, it's a text editor that renders in color, right? So you can go in there and mess with the pixels, which is like the point. All right.